Hey there. Partway through the build already, but I figured it better late than never to make the intro for this. But should probably explain what exactly I'm doing. Right now, I'm trying to design and build a type of three-phase AC generator called a Axial flux generator. They're pretty nice, more compact than the other kind of generators out there, which is why it has the nickname flat or pancake generators. I saw a couple of people on YouTube. They were assembling their own versions, motor versions as well, which is just reverse polarity. And they were getting some pretty impressive speed, so I figured I want to try to make my own up. They didn't show any kind of build design or anything like that, which I'll try to include here so it's kind of more accessible. It was also in a different language, so that might be a little bit of an issue there. I don't speak French. But one of the main reasons, or one of the few reasons that I wanted to make it, is so I can learn three-phase conversion, a little bit about electromagnetism and CAD design for other projects that I want to work on. Hopefully I can learn and hone those skills down so that I can get a pretty good start on some of the projects that I have. A lot of the materials that I'll have, they're going to be in-house. I have a 3D printer. It's just an Ender 3, like the version 1 or something like that. But it does a pretty good job of making like the housing parts and other pieces that are going to be going onto the internals of the motor. The PLA that I have is about 1.75 millimeters, and that can get down to some pretty close tolerances, so I don't worry too much about that. And in addition to that, there's a lot of steel and stuff around this area that I'm going to be working out of, and it's a fabrication shop as well, so I've got access to a lathe, mills, different things like micrometers and stuff like that, presses and things that I can use to get these things to the point where I can work with the tolerances. I can list all the sizes and stuff at one point, like where I got it, like magnets, wiring, etc. A lot of this stuff could be coming from Amazon, eBay, whatever, but I can post a link on those kinds of things below. In order to test all this stuff, I have no idea. I have the basic principles in my mind, and I've seen how it works. So plugging in my stuff and developing my stuff, I'm sure I'm going to run into plenty of troubles, especially with the integrity of the prints. That's one thing that I'm worried about. I'm printing at a 65% infill. I should probably be 100%. Stuff like that. Little bits here to develop and tune it. And I'm totally fine with people with constructive criticism and thought out insight on what I'm doing, so that I can kind of understand this shit a little bit better. But basically, I'm making the internal housing of 4 separate plates of 2 different kinds. 2 of one kind will house my magnets, 16 on each plate, or a total of 32. I'll call these my pull plates. And the other 2 will house the winding, 12 each with a total of 24, and I'll call these my stator plates. These numbers are important in AC electric production because you need a number of windings divisible by 3, and a number divisible by 4 for the poles. And typically you'll run those pretty ratioed. So with every 3 coils, you're going to be adding 4 poles onto it. And you'll just keep going with that. So like 3, 6, 9, 4, 8, 12, like that. The pull plates will be fixed to a shaft. I'm not sure what the diameter will be yet. That's still in development. Like trying to get an idea of, how strong it has to be, how big the center should be so that it's more supported. And those are going to rotate freely in the housing. On the inside of both of these plates are the stator plates, and those are going to be facing the opposite direction of each other towards the polar plates. That's where a lot of the electromagnetic generation is going to be happening. All of it, or most of it. Or these plates are going to be fixed to the center housing, and it'll also be hooked to the external housing of everything, so the outside build of it all. The outer shaft will probably have two bearings on the outsides to support the outer ends of the shaft. That way it can run a little more true. The magnets, in theory, should cause the turnable pull plates to rotate on the bearings and generate some kind of rotation. This is what I'll be printing on. I've got standard 1 3/4 silk PLA filament. I print at a relatively high temperature, so it's a good mold on there. So I just sprayed it off with some Windex, cleaned it off with some paper towels, and then just got to get this paper is basically what I use to measure the distance between the build plate and the nozzle. So once I get all that taken care of, I can start the build. That I've got this pretty much weighed out. I was going to record it, but I don't have enough hands. But you basically just run this under so you feel light drag. It's a good distance for the level of filament or the size of filament. I'm doing a pretty high infill, so about 60%. This will take about 5 hours. I'm going to print from right here. And that's my axial magnet tray, so I'll go ahead and start on that. My preheat options, I need to change. Nozzle should be, let's say, about 200, a little over 200. So 210, and then bed I'm going to bring up to a good 60. 100% span. That should be everything. Yeah, this should be good. Had to do a little bit of J-rigging, but there we go. Hey everybody, so this is a little bit of an update. These are a couple of the magnetic trays that I printed off. I like the way that they came out. You can see down the future where I might want to go a little bit thicker on this shaft, but we're going to run with it. And as you can see, this is where these individual magnets go into. There should be 16 on each one of these, so it's going to be 32 again with 12 coils. And I've got this pulled up on ThinkerCAD. They do a pretty good job of I mean, you can make just about anything on there if you're clever enough. Another thing that I've been using is my Oculus. A lot of these STL files can be rendered in virtual reality, so I can take each individual piece and put it into a project that I'm doing on there, and I can look around, see if what fits, what looks right, what isn't going to work. But essentially, what I have printed right now are these two outside pieces. Those are going to be my poles, and currently, I am printing out the one of the stators, which will be an internal piece there. It's that right there is the framework for it. It's going to take a few hours. I think it's about 5.5 hours per disc. That's because I'm limited by obviously the equipment that I've got and how fast it can print and everything. But I want it to be good enough that, hey, maybe I can get a lightweight version of this thing to get running. But I think I'm probably going to go with the larger shaft size, and then we're thinking I'm probably going to need to put a boss on the outside of this so that it squeezes in and really kind of keeps it from wobbling on there, because I'm working with thinner plastic and higher RPMs. They don't really like to work all that well together. The framework for these, this is just what came out from under this thing so it could build the way that it did. Basically, it just built like this, so it had framework to build up on this first section. You can see it's not the best, but after the first pass or so, because this is also the bottom tray on this, so it's a real thin piece. Um, but that's what that's built on, and this thing seems to be pretty stable. I'm not sure if I'm going to have any use for it, but the fact that it does have a little bit of a variable space in the center for the shaft could be useful for something. I don't know. I could use it as a big spacer. It's lightweight, a lot of air breathability that's running through. So yeah, that's pretty much where we're at right now. We've got magnets on the way. We've got 22 gauge wire that I'm going to be doing the windings with. And I have that all figured out here. Your rules of threes and fours on your coils and poles. I was thinking about a Hallbach array, but honestly, with these, I wasn't sure how I was going to get the space fit in there, and I really just wanted to prove the concept that in itself that I could just get it to move and then work from there. Making beefier components and increasing the power supply, RPM, and all that kind of stuff. Um, so once I get everything taken care of and put together on that aspect, I do need to make an external housing that's basically just going to put everything together, hold these outsides. I'm going to run probably 2 bearings on the internals, on the stators, and then on the housing that's going to go around the outside, I'm going to put another housing for bearings. That way I've got 2 keeping it centered in the middle, and then I've got the 2 on the outside that are going to be kind of stabilizing the further apart. This bottom section right here really just kind of, this isn't even the updated version of it. Just going to get set in there. I'm probably going to build up the walls so that they're not actually points. They're going to get lined up pretty well, and then those pieces will set inside of them. They've actually been, if I were to identify and kind of tear these objects apart, these ones right here are actually a series cut out from here. So I use these discs to make a hole within these posts, so that I know that it's going to fit perfectly, because whatever it's printing out on here, the negative will be on here. And if it's got steps to it, which it does on Thinkercad, I think the maximum sides that the sides that you can have on a spherical surface is like 63 steps or something, or 64 steps. So it's not going to be perfectly round, but we can fix that on the lathe. That's pretty much where we're at right now. After I get everything put together, the next step after that would be using a rectifier to get the 3-phase to 120. And I think trying to figure out what voltage supply that I want to run to this thing, what the total hours that I can run it for is going to be down the road. But that first step of getting the rectifier installed and getting the power running through it properly and just seeing it move is going to be the first step onto developing to the next stage. Hey guys, hopefully you liked that video well enough that you can press that little thumbs up, and if you like me enough, give the channel a subscribe to see where my projects go.